Hey, this is Math 6, Unit 7, Lesson 1, Positive and Negative Numbers. So we're going to be looking at this next unit about positive and negative numbers and talking about rational numbers and how those all work together today, or the next couple lessons I should say. So first we begin with this notice and wonder picture, and we have some different weather situations happening. One in Tennessee and one is in Bangor, ME. I'm not sure what ME stands for. Sorry, I should have looked that up ahead of time, right? Maybe that's, I don't know, Maryland? I'm not really sure. I don't think so. ME, I don't know. Anyways, so here's our weather. We have some things to notice and wonder. I kind of wonder what ME stands for. Oh, maybe it's Maine, actually. I don't know. Anyways, so we have, what do you notice, what do you wonder? We have different temperatures here. We have kind of rainy conditions here, partly cloudy there. We can see that in both places we have a Fahrenheit and a Celsius temperature in both places there. In one of them, the Fahrenheit degree is positive and so is the Celsius. When I look over here, this one has a negative number there. I'm going to assume that these are the same temperature, but one using the Fahrenheit scale and one the Celsius scale. I can see that one is at 5 o'clock p.m. and one's at 6 o'clock p.m. Definitely different weather conditions happening in both. And what's interesting is this one's positive and that's positive, and like we said, this one starts at positive and the other scale has a negative. So it makes me wonder, why is that the case? What's the difference there between those two things? Okay, so a couple different cities, two different temperatures for each city. We have Fahrenheit, Celsius, and this one is a -17. Things you might wonder about. Okay, well, let's move into today's lesson activities. First of all, in lesson activity number 2, called Above and Below Zero, it says here are 3 situations involving changes in temperature and 3 number lines. Represent each change on a number line, then answer the question. Okay, so we have A, B, and C. So let's use this one for A, we'll use this one for B, and this one for C. For the first one, it says at noon the temperature was 5 degrees Celsius. Okay, so let's go over here and use this, make this like our temperature gauge here. I'm going to zoom up a little bit there. Alright, so we're going to go to 5. So we're at 0. Let's count up 1, 2, 3, 4, 5. So here's 5, and we're going to start right there. I'm going to draw a circle just like I had circled the 5 there. And then it says by late afternoon it has risen 6 degrees. So the temperature has gone up 6 degrees, hasn't it? Alright, so it's going to go up 1, 2, 3, 4, 5, 6 to this point here. It's going to go up 6 degrees starting from the 5 where we started at there. What was the temperature by the late afternoon? So starting at 5 and going up 6 more, what is the temperature in the late afternoon? So in this case, we're essentially saying we're starting at 5 and we're going to increase by 6 more. So the new temperature is going to be 11 degrees Celsius, because we can see we're at 6, 7, 8, 9, 10, and we stop right here at this point, which is 11 degrees Celsius. Okay, well, that worked out pretty well, but we're talking about some positive numbers, just increasing temperature, no problem at all. Look at B. It says the temperature was 8 degrees Celsius at midnight. So let's find 8 on our scale. We have 1, 2, 3, 4, 5, 6, 7, 8. So this is 8 where we're starting at. 8 degrees there. By dawn, it has dropped. Now, drop means we are decreasing, we're going down, and it's dropped 12 degrees Celsius. So at midnight, it's 8, and by dawn, before it starts to become morning, or morning starting up, it drops 12. So we're going to go down 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 to this point right here. So my arrow is going to go all the way from here down to there, and we're going to stop at this point right there. So the new question is, what's the new temperature at dawn? Notice though that we went past 0. Okay, this is important. So while this is 1 and then 0, when I go down, now we're going to start talking about negative numbers. -1, -2, -3, and in this case, -4. So we know that what happens here is that while I'm starting at 8, dropping down means I'm going to go down, so I'm going to subtract 12 degrees. And 8 minus 12 is going to be -4 degrees Celsius. So right here, this becomes our new temperature at -4 degrees Celsius. In part C, it says water freezes at 0 degrees Celsius, but so water freezes here at 0. Awesome. But the freezing temperature can be lowered by adding salt to the water. Right? This is what I do when I make ice cream. Okay, your ice cream maker, you make one of those. You put some salt in the ice to make it lower the freezing point. A student discovered that adding half a cup of salt to a gallon of water lowers, which means we're going to do what? It's going to decrease its freezing temperature by 7 degrees. What is the freezing temperature of a gallon of salt water? So we're going to lower it. We started at 0 and we're going to lower it 7 degrees. 1, 2, 3, 4, 5, 6, 7 to this point right there. So we come out and we're lowering it 7 degrees, right? We're going down 7. And so what's the new temperature? Well, -1, 2, 3, 4, 5, 6, 7. We're at -7 degrees Celsius. So in our case, in this one, we're doing 0 minus 7, which becomes -7 degrees Celsius. Okay, so we can see with the number line here, we have our 0 point, and everything on this side is positive. Over here, we're all negative. Same there, and same there. Okay, but we use a temperature or thermometer to show the differences between a positive temperature and a negative temperature in terms of degrees Celsius. Okay, that's how it works. So the thing they want to talk about next to your partner is, how did each of you name the resulting temperature in each situation? Like, what'd you call it? And what does it mean when a temperature is above 0, below 0? And do numbers less than 0 make sense in other contexts? Like, can you use numbers that are less than 0 in other situations? So when we looked at these ones here, like 11 degrees Celsius, you might have said 11 degrees Celsius, or you could say 11 degrees above, right? This is above over here. 0. Over here you might call this 4 degrees below 0. That's what we call this right there, 4 degrees below 0. But it's also -4 degrees Celsius. And here this could be 7 degrees below or -7 degrees Celsius. So there's different ways we say that. Okay? So above just means that it's a positive kind of value, and a below means it's a negative value. And other things you might use negative numbers for, maybe you're talking about things like an elevation, how tall something is, if you're going up a mountain, or if you're down in a valley down below, maybe elevation might be something you talk about. And maybe going down underground would work as well. So those are some examples where you might use numbers less than 0. Okay, so let's take a look at activity number 3. High places, low places. It says here's a table that shows elevations of various cities. Okay, now again, let's keep in mind how this is going to kind of work out. Okay, so if you're not familiar with this a little bit, let's draw a little picture. If I have the ocean, these are my sea waves. I know, it's beautiful. That's my ocean. And the ocean hits the beach. And the beach, at some point, maybe there's a mountain. And the mountain on the backside then has a valley, like maybe goes below that, and then it goes back out there. Okay, this sea level right here represents what we call 0. So sea level has an elevation of 0. That's just where we start from. If I climb up to a mountain up here, this is going to be some sort of positive elevation over here. But if I was to hike down the mountain and go down in this valley and go below sea level, I would have a negative elevation down there. Okay? So in this picture here, this chart, we see various cities and what their elevations are going to be in terms of its relationship to what the sea level is going to be. Sea level is our baseline, it's our 0. Right? And not that the sea covers the whole land, we're just showing that that is sea level all the way across the land. So these are the elevations of different cities in the United States and in relationship to sea level. Okay? So now let's answer some questions. On the list of cities, which city has the second highest elevation? So that's going to be the greatest positive value, but not the greatest, but the second greatest, I should say. So our greatest one is Denver at 5,000. So the one that came in second is right here at 1,211 at Bethel, Indiana. So Bethel, Indiana, has the second highest elevation at 1,211 feet. How would you describe the elevation of Coachella, California in relation to sea level? Well, Coachella is at -22. So what is that telling us? Sea level is here at 0 and it's down here at -22. So we would say that it is 22 feet below sea level. Okay? 22 feet below sea level. How would you describe the elevation of Death Valley in California in relation to sea level? Well, Death Valley is here at -282. So we would say that it is 282 feet below sea level. Now, is it still negative? Well, it's negative in the sense that if you go this way, we write that as a negative number. But you could actually measure that as being 282 feet. Okay, so that's why we write 282. If you're standing on a beach right next to the ocean, so you're standing right here, there you are, right next to the ocean, what is your elevation? If you're on the beach, then you're probably going to be at sea level. So we pretty much say your elevation is 0. You're just right there. Just like if you're at Miami, Miami is already at 0. So how would you describe Miami? You would say that you are at sea level in Miami. Now again, when you're on the beach right next to the ocean, you're pretty much at 0. Now sometimes the beach might have a little bit of a dip there, right? You might be 10 feet above sea level if there's a little dip there. But again, for the most part, you're at 0. All right, letter F. A city has a higher elevation than Coachella, California. Now Coachella, it said, was at -22 feet. That's Coachella right there. Select all the numbers that could represent the city's elevation. So we're looking for a number that is higher than -22. Okay? So if we're talking about elevation higher than -22, we could think about it being like on a number line, like so. And if this is 0, and that's where we're going to be here, I have -22, which would be somewhere like, let's just put it right here, -22. And let's plot the other points. Now, anything higher is going to be anything on this side of the 22. That's going to be higher. But if it's on this side, it would be lower because it's less than 22, -22. So -11 is going to be somewhere about here. So that's higher. -35 would be over here. So that would be lower. 4 feet's on this side of the 0. That's higher. -8 is over here. 0, -8, -11. That's good. And of course 0 is already there. And that's higher too. So we would say that -11, 8, 0, and 4 feet are all on the higher side than Coachella's -22, but the -35 is definitely going to be lower, so it doesn't get checked off there. Okay, let's look at the next table. The next two tables show the elevations of highest points on land and lowest points in the ocean. Distances are measured from sea level, so talking about sea level. So this is our land stuff, right? Different mountain points, and these are in the ocean, different trenches in the ocean. So for our first question, it wants to know, let's see if we can make sure I can see it all. Which point in the ocean is the lowest in the world? So what's our greatest number over here? Or our greatest, or I should say greatest absolute value number. The largest absolute value number is going to be right here at -11,033 meters, which is in the Mariana Trench. So the lowest elevation is 11,033 in the Mariana Trench. Okay, that's the lowest elevation and where it's located. Now in terms of which mountain is the highest in the world, we look for the greatest number, which is over here, at Mount Everest, which is 8,848 meters. So 8,848 meters. Okay, and that's going to be Mount Everest in Asia. If you were to plot the elevations of the mountains and trenches on a vertical number line, what would 0 represent? So what would the 0 be if you're plotting the elevations of all the mountains and stuff? Okay, so 0 is going to represent what? 0 is going to be where the sea level is at, because everything it said was all the distances it told us in our first directions were what? Measured from sea level. So sea level is our 0 spot. So 0 represents the level of the ocean. Points above 0 represent, in our case here, if they're above 0, represent positive numbers, usually positive values or positive heights above sea level. And points below are going to be negative values below sea level. Which makes sense because these are all inside or below the ocean line, right? So part D says, which is farther from sea level, the deepest point in the ocean or the top of the highest mountain? Well, our deepest part of the ocean was negative 11,033 meters, and our highest point was 8,840 meters, and 0 is going to be somewhere in between there, right? So we're talking about the space between these. If this is like a number line, okay, this is our number line. The question is, which one has the greater distance from here to here? This one or this one? Well, the distance from 0 is always what we call the absolute value. The distance from here to here is 8,840 meters. The distance from here to here is 11,033 meters. It's the absolute value. It means you just kind of ignore the negative sign there, okay? That's the actual distance. This is its location, but the distance is the absolute value. So which one has the greatest distance from 0 is the one with the greater absolute value. We would say this one here, 11,033 meters. So the deepest point of the ocean is further away from the sea level than the mountain peak is. So it's kind of fun to think of that when you think about a picture of the highest mountain in the world, Mount Everest, and you go, oh, that's a giant mountain. But there's a spot in the ocean that is even lower than what that is in terms of its height. So if you put the Mount Everest in the water and flipped it over, it would fit in there with no problem and have space left over. Kind of crazy. Alright, so let's look at our summary. In summary, positive numbers are numbers that are greater than 0. Negative numbers are numbers that are less than 0. The meaning of negative numbers in a context depends on the meaning of the 0 in the context. So in this one here, in the thermometer, the 0 meant in this case here, the temperature at which water freezes. When we were talking about the elevation, the 0 meant sea level. So that 0 means different things depending upon what you're measuring and what you're working with, like what they call the context there. Okay, so that's the main point right there as well. Let's look at the next page real quick of the summary. It's important because it helps you with your homework a little bit. Okay, and that is that another example is elevation, and we talked about that here. So, which is the distance above or below sea level. An elevation of 0 refers to the sea level, and positive elevations are higher than sea level and negative or lower. Now, let's take real quick this octopus here. Here he is down here, or squid, or whatever he is, at negative 10 maybe meters below 0. What would happen if we said, if he or it swam up 8 meters, what would its elevation be? And that's a question you're going to have something similar to in your homework tonight, okay? So he's starting right here at negative 8. If he was to go up 8 meters, then we're going to be taking where he starts, negative 10, and because we're going to go up 8, we're going to add 8 to that, and it's going to give us a new location, which in this case would actually be negative 2 meters, so it's still 2 meters below sea level, because a negative 8 and a negative 10 and a positive 8 becomes a negative 2. So sometimes when you go up, you're just going to add, and you still may be in the negative, but you've increased and gotten closer to sea level. Okay? Alright, we're going to pause there. You're going to be able to work on your homework, and we'll come back together and check that in just a few minutes. All right, there's homework time. Positive, negative numbers. So here we go. Is a temperature of negative 11 degrees warmer or colder than a temperature of negative 15 degrees? All right, so we think about a scale. So let's just draw a little number line here like so. And we'll put 0 right there. We have negative 11, like this is negative 1. So negative 11 would be here. We keep counting down negative 15. Now the lower I go, the colder it's going to get, isn't it? So 11 degrees is above 15, so it's actually going to be what? It's going to be warmer. In terms of elevation, is an elevation of negative 10 feet closer or farther from the surface of the ocean than an elevation of negative 8 feet? So if we did a negative 8, it's going to go, let's put negative 8 there, and negative 10 there. So is negative 10 feet, this one right there, closer to sea level at 0 or further away than an 8? Well, 8 is here, 10 is here. It looks to be further away, doesn't it? So it's farther from the surface, based upon what we see. It was 8 degrees at nightfall. The temperature dropped by 10 degrees. So we started at 8, and it dropped 10 degrees by midnight. What was the new temperature? So we started at 8, and we dropped 10. Well, 8 minus 10 is what? Negative 2 degrees. And the next one, the last one here, a diver is 25 feet below sea level. So what does that mean? What's his location? Negative 25, because he's below sea level. Then he swims up, so we're going to be adding 15 feet. Swims up 15 feet toward the surface. What is his elevation? So he started at negative 25 and went up 15. The new elevation will be 25 minus 15, which is 10, and we keep it negative because this has a greater absolute value. So we're going to be at negative 10 feet is the elevation. Again, that comes back to our little summary. We talked about the octopus being at negative 10 and going up 8. Same idea. All right, number 2. A whale is at the surface of the ocean to breathe. What is the whale's elevation? So it's at the surface, so the elevation at the surface is what? 0. Okay? The whale swims down 300 feet to feed. What's the elevation now? So we started at 0 and we went down, so we subtract 300. So 0 minus 300 is negative 300 feet. The whale swims down 150 more feet. So we started at negative 300 already, and it goes down another 150. When I subtract, it's like adding the opposite, or adding a negative. The signs are the same, so I find the sum, and I keep the sign the same. So the new elevation is negative 450 feet. Plot each of the 3 elevations as a point on a vertical number line and label each point with its numeric value. Okay, so here's our vertical number line. We started at 0. He dove down to 300 there. And then he went down another 150 more to negative 450. So we went here and then to here. And that's what the whale did. All right, explain how to calculate the number that is equal to that right there. So your explanation doesn't actually want an answer. You could do that. But how we would do that is we would do long division. That is what you would have to do for a problem like this. To do long division, we would put the 1.5 on the outside, and we would put the 2.1 on the inside. I move the decimal over, which, you don't have to, but you can. Move the decimal over and the decimal up. And 15 goes in 21 one time. 15 there. 21 minus 15 is 6. I am not quite done, so I have a 0. I'll bring that down. 60. 15 goes into 60 a whole 4 times for an even 60 with no remainder. So we would say the solution is 1.4, but it really wants to know how would you do it. Number 4. Write an equation, represent each situation, and then solve. So we want to write an equation and solve. Andre drinks 15 ounces of water, which is 3/5 of a bottle. How much does the bottle hold? So what do we know? That 3/5 of a bottle is 15 ounces. So 3/5 of the bottle is 15 ounces. He drank 15 ounces of water, which was 3/5 of the bottle. How much does the bottle hold? Well, the bottle is here, so let's just convert this into an equation. This becomes 3/5 of is to multiply, and we can use B for bottle. Is equals to, and it's equal to 15 ounces. So 3/5 times the B bottle equals 15. That's our equation. To solve it, we're going to multiply by the reciprocal, 5/3, 5/3, in order to get the B by itself. That cancels out. So B equals 15 times 5 divided by 3. I can reduce. That becomes a 1. That becomes a 5. And 5 times 5 is 25 ounces. So the size of the bottle is going to be 25 ounces. Just like that. Okay? You do need to get comfortable converting sentences into equations. Okay? Just don't be afraid of the words. Look at what you have and just think about what it's asking you to do. A lot of times there's enough vocabulary in there to help kind of give you clues. Here are two more. Again, good to be able to read this here. A bottle holds 15 ounces of water. So we have 15 ounces of water in a bottle. Jada drank 8.5. So how many ounces of water are left in the bottle? A couple ways of setting this up. I look at it and says she had 15 ounces, right? She drank 8.5, which means of what she had, she got rid of 8.5 ounces. How many ounces of water are left in the bottle? How much water is left? That's what I'm looking for. So as a subtraction problem, I could write it like this. That would work out just fine. Some people might want to say, well, let's do an addition problem. You could do the water of what's left plus the 8.5, what she drank, would give you how much there are to begin with. This is the same type of equation, just a different way of approaching it. Okay? So 15 minus 8.5 is going to give you actually 6.5 equals how much water is left in the bottle. And if you had this one, you would do what? You would subtract 8.5 from both sides. And what do you end up with? You end up with 15 minus 8.5, which is exactly what we had right there. So W equals 6.5. Last one of these ones says a bottle holds Z ounces of water. Okay, so the bottle has Z ounces of water. A second bottle holds 16 ounces, which is 8/5 times as much water. How much does the first bottle hold? Okay, so what do we know? The second bottle is 16 ounces, and 16 ounces is what? Is 8/5 times as much water as the first one. So 8/5 of the first one, Z. So 16 ounces of the second one is 8/5 of the first one. Now we want to get the Z by itself, so we'll multiply by the reciprocal. Multiply by the reciprocal. We reduce 1, 2, 5 times 2 is 10. And so we would say that the first one holds 10 ounces. And finally, number 5, a rectangle has an area of 24 square units. A side length is 2 3/4 units. 2 3/4 unit. Find the other side length. We'll call that X. Area is found by multiplying the two side lengths together. So 2 3/4 times X is going to be equal to our given area of 24. Now to solve this one here, it'd be helpful to turn that into an improper fraction. So 4 times 2 is 8. 8 plus 3 is 11. So we have 11 over 4 times X equals 24. We'll multiply both sides by the reciprocal. So this becomes eliminated there. And X equals, I really can't reduce 11 and 24. Can't do much about that. So I multiply 24 times 4 is actually 96 over 11. And I can rewrite that as a mixed number. 11 times 8 is 88, right? 88. So I do 96 minus 8. That'll tell me what's left over here. I have 8 left over. So I end up with 8 left over out of 11. So I have an 8 at 8/11 becomes the other side length. And that's it for today. Hope that helps you out a little bit, and we will see you next time.